This is section 3.6, derivatives of logarithm functions. The first thing that we're going to look at is we can use implicit differentiation, what we used in the last section, to find the derivative of a logarithmic function, y equals log base b of x. I'm going to go ahead and use the change of base formula, which says that this is equal to ln of x over ln of b, which is the same thing as 1 over ln of b times ln of x. And so taking the derivative of this, we have dy dx, taking the derivative of y with respect to x, is equal to 1 over ln of b times the derivative of ln of x. And so what we're going to be using is the derivative of ln of x is just 1 over x. So this simplifies to 1 over x ln of b. So down here, give this box a star. This is definitely something that we need to know. Should have those memorized. And then moving on to the next page, there's another derivation of one of our derivatives. I'm going to go ahead and leave that for you guys to do on your own. But right below that is another box that we will star. And these are definitely formulas that we need to know. And these are derivatives of natural logarithms. And so really quick, notice that there's absolute values in here. And again, you need to be careful because that value needs to be positive that you're taking your log of. So just be careful of that. So the next thing is examples. They say differentiate the following. So the first one says take the derivative with respect to k of log of 1 over k to the second. So I'm going to write this as log base 10 of k to the negative second power. And now I'm going to take the derivative of this function. We'll say dy dk. And from here, we're going to take log base 10, which was on the previous page that we had, and that was 1 over the value that we're taking the log of, k to the negative 2, times ln of our base, which is 10. And since this is an outside function and an inside function, we have to use the chain rule and multiply by the derivative of the inside, which is negative 2k to the negative third. And again, this is cleaning this up quite a bit. Let's go ahead and look at the next one. The next one says take the derivative with respect to x of log base 2 of x cubed e to the negative x. Again, remember that this has an inside function, but I also want you guys to realize that this time it doesn't just have one thing, it has two. So we're going to have to use the chain rule and the product rule. So let's go ahead and put dy dx to show we have our derivative. We're going to have 1 over what we're taking the logarithm of, which is x cubed e to the negative x, times ln of the base, which is the same we have base 2, times the derivative of the inside function. This is the chain rule. And again, with the chain rule here, we need to realize that we are using the product rule. So it's going to be the first term times the derivative of the second, and the derivative of the second would be negative e to the negative x. I'm just going to go ahead and put that negative out in front, plus the second term, which is e to the negative x, times the derivative of the first, which is going to be 3x to the second. From here, clean this up and see if you guys can get the answer that's posted on Canvas. So we're going to try one more on this page. I want you guys to take a second and look at D. We'll come back to C later and try it on your own. And with D, this says the derivative with respect to theta of ln of cosine of theta. And again, remember those absolute values are there. It's because cosine does take on negative values, and we're only looking at the positive since we are dealing with a logarithm. So we have dy d theta is equal to, and the derivative of an ln of x would be 1 over x. But again, we have that inside function, so we are going to have to use the chain rule. So it's going to become 1 over cosine of theta times the derivative of cosine is going to be negative sine theta, which equals negative tangent of theta. Again, look at C or continue on to the next page.